Okay, guys, welcome. Today we're going to talk about savings plans and investments. Okay. Now, the reason why we need to talk about saving plans and investments is because if you look at the first paragraph here, we say that most people don't have a large sum of money to dump into an interest-bearing account to grow over a long period of time. For example, at the end of the last video, we discussed an example where if we wanted to accumulate $100,000 in 18 years, we would have to have that initial deposit be $58,000. And of course, most people don't have $58,000 lying around. So instead, a more realistic way to save money is by depositing smaller amounts on a regular basis, right? So for example, you might put $50 a month into a savings account or something like that. Now, there are some like retirement accounts and savings plans that that are available to you. Once, and a lot of them are sort of available to you through a company that you may work with. And those are things such as individual retirement accounts, 401k plans, and 529 plans, right? So those are some examples of some savings plans. Now, the savings plan formula, which you can, which is accumulated by regular payments, is something like A is equal to P times 1 plus R over N to the N times T minus 1. And we divide all of that by R over N, right? Now here, everything is essentially the same, except we say that A is the accumulating savings plan balance, or you can even think of this as the final amount still. And your P is the regular payment or deposit amount, right? And of course, R is the interest rate as a decimal, N is the number of periods per year, and T is the number of years, right? Sometimes this formula is even referred to as a future value formula, right? And the reason why we have future value is because you're looking to end up with some amount of money in the future, right? So that lump sum is designated to be in the future. Right. So first we'll use the savings plan formula to calculate the balance after 6 months for an APR of 12% and monthly payments of $100, right? So again, the formula we're using is A is equal to P times 1 plus R over N to the NT minus 1 all over R over N, right? So here we have that the balance after 6 months is interesting because T is the number of years. So 6 months is actually 1/2, right? And then of course our APR, our interest rate, is 12%. And monthly payments, so our P value, is 100, right? And of course N is 12 since we're making monthly payments. So if we plug all this stuff in, we're going to have 100 times 1 plus 0.12 over N, which is 12, to the 12 times 1/2, so just to the 6th minus 1, all over R over N, so 0.12 over 12. All right, now when you enter this in the calculator, you have to be very careful with your parentheses, right? So I'd make sure that this whole denominator is in parentheses, and be careful with these sets of parentheses, all right? But anyway, if we enter this in, we want to do 100 times parenthesis, 1 plus 0.12 divided by 12, and then close that. Oops, I missed a 1 there. Okay, so I missed that. So 12, close that, and then raise that to the 6, and then minus 1 parenthesis, and then divided by parenthesis 0.12 divided by 12. So looks like we're going to get that we're going to have $615.20. And of course, this makes sense because each month we're depositing $100. So we should have $600 right there. And if we have $15.20, right, that's a reasonable amount of interest for 6 months, right? So it looks like after 6 months of depositing $100, we'll be up to, sorry, yeah, 6 months of depositing $100 will be up to $615.20. Okay, let's look at another example. So at age 30, Michelle starts an IRA to save for retirement by depositing $100 at the end of each month. If she can count on an APR of 6%, how much will she have when she retires 35 years later at age 65? So we're going to compare the IRA's value to her total deposits over this time period. So again, we're using the same formula. A is equal to P, 1 plus R over N to the N times T minus 1 all over R over N, right? Well, in this case, our regular payment amount is $100. Our interest rate is 6%. Our N is how often we're making the payments, so that's monthly, so 12. And T is 35 years later. And let's see, am I missing anything? I don't think so. So I think we're ready to go, right? So now we're going to find out how much she has after this 35 years. So we get A is equal to 100 times 1 plus 0.06 over 12 to the 12 times 35 minus 1 all over 0.06 over 12. All right, so again, make sure we're very careful, enter this into the calculator. So we have 100 times parenthesis 1 plus 0.06 divided by 12, close that, raise that to the 12 times 35, and again, make sure that that exponent is in its own set of parentheses. Okay, then minus 1, and then divide all that by a 0.06 divided by 12. All right, so it looks like we're going to end up with $142,471.03. So that's how much we can expect to be there after the 35 years, right? So for $100 at the end of each month. Now, of course, compare the IRA's value to her total deposits over this time period. Well, her deposits, right? So without the interest, were $100 per month for 12 months a year for 35 years. Right, so we're just going to multiply all these together. So it's 100 times 12 months a year for 35 years. So if we multiply these, so if I do 100 times 12 times 35, we're only putting in $42,000. Right, so you're seeing that you're gaining quite a bit of interest. You're gaining over $100,000 of interest by putting it into this account. All right, so you can see the power of using this, using a savings account like this, right? So just depositing the money without interest, you're at 42,000, but with the interest, you're now over 142,000. Okay. So for example, a popular scenario that arises for savings plans occurs when a particular savings goal is taken into account. So for example, you want to end up with X amount of money in the future, right? So for example, if you wanted to have a certain amount of money in order to retire, it would be helpful to know what you would have to deposit each month in order to get there, right? So what we're going to do is we're really going to essentially use the same formula, right? We're using A is equal to P times 1 plus R over N to the NT minus 1 over R over N. But if we want P, then we just need to multiply both sides by the reciprocal. So we would get that P is equal to A and then times R over N, and then we have the original top down here. So we get the 1 plus R over N to the NT minus 1. Right? So that's how you could find out what the monthly payment should be. All right. So we're going to do an example of that here. So we want to build a $100,000 college fund in 18 years by making regular end-of-the-month payments. So assuming an APR of 3%, calculate how much you should deposit monthly. How much of the final value comes from actual deposits and how much from interest. So again, same formula. All over R to the N. And of course, what's going to happen here is that we're going to want to be solving for P. So really our formula is going to be P is equal to A times R over N all over 1 plus R over N to the NT minus 1. All right, so here we know that A is 100,000. Right, we know that our R is 3%, so that's 0.03. End of the month again, so N is equal to 12, and T is equal to 18. So in order to find this, I have to do 100,000 times R over N, so 0.03 over 12. And we're dividing that by 1 plus R over N. Oops, we know R over N now. 0.03 over 12 to the 12 times 18 minus 1. All right, so again, we'll let the calculator handle that. So I want to make 100,000 times 0.03 divided by 12 and divide all of that by parenthesis, 1 plus 0.03 divided by 12, close that and raise that to the parenthesis 12 times 18, and then subtract 1, close the whole thing. And we're going to get that we should be depositing $349.72 for each month. Right, so if we want 100,000 in 18 years, then that's what we'd have to put in. Right? Now, how much of the final value comes from actual deposits and how much from interest? Well, let's take a look. So actual deposits, I would need to make monthly payments of $349.72. I would need to make that 12 times per year for 18 years. Right? So of course, if we multiply this, so 349.72 times 12 times 18, if we do that, we're going to get that this is $75,539.52. Right? So of course, the interest would be the remainder of that, right? The interest would be 100,000 minus the 75,539.52. And then that would give us a $24,460.48. So this is from interest, and this is from deposits. All right. So that's sort of the idea behind this example. Okay. Now, in the next example, we have something interesting. We would like to retire 25 years from now and have a retirement fund from which we could draw an income of $50,000 per year forever. All right, we want to know how can that be done? And we want to assume a constant APR of 7%. So let's take a look. So what we want to have happen is we want to accumulate some amount where we can afford to take out $50,000 per year. All right, so let's go ahead and let's take a look. So same formula. And then over R over N. Okay. So we want to know what the deposit should be in order for me to take out $50,000 each time, right? So what we need to do here is we need to have it so that our A is whatever we're starting with, whoops, plus 50,000. right? Because we need to be able to gain $50,000 in this period here, right? So what this is going to eventually become is that we have P plus 50,000, because that's now my A, is equal to P, and then we can fill in all this stuff, right? So we want to have 1 plus 0.07 over N, so 12, to the N times T, so we're going to have 12 times 25, and what we need to do at that point, okay, so what we actually need to do is the following. So the first thing we need to do is we need to figure out, well, how much money would we need to have in the account in order to have just the interest alone generate $50,000 per year, right? So what we need to have happen is we need an APR of 7% times our investment, which I won't use X, let me actually use A. I need that to come out to be $50,000, right? So just to get the interest. So dividing by 0.07, we're going to get that A is whatever 50,000 divided by 0.07 is. And then that will give us that we need to have $714,285.71. Right? So that's how much that needs to be in there in order to generate $50,000 per year in interest alone. Right? So now what we can do is we can now solve for the payment amount that would get this. Right? So now I need to solve just like before when we had P is equal to A times R over N to the 1 plus R over N to the N times T minus 1. We can solve for the payment amount. So now we have that the payment is $714,285.71 times our interest rate, which is 0.07, divided by 12, and then a 1 plus R, which is 0.07, divided by 12 to the 12 times 25 minus 1. Right, and now we can calculate, well, what do we need to put in for 25 years each month in order to end up with this amount? So we take 714,285.71 and then multiply that by 0.07 divided by 12 and divide all of this by parentheses 1 plus 0.07 divided by 12, and then raise that to 12 times 25, and then subtract 1. And if we do that, it looks like our payment would need to be $881.76. Right? So you're having to put away quite a bit of money each month, but the payout is that you can take out $50,000 a year, and you can do that for as long as you would need to. Right? So you would have a yearly income of $50,000 without working. Right? So that would be, of course, a good thing. Okay. Now, the last couple things that we're going to talk about involve total and annual return. And the reason why is because that most of the time interest does not remain constant. Usually it's going to change frequently with time. Right? Now, your total return is the percentage change in the investment value over a certain time period. Right? And you can find out what the total return is by finding the percentage change of the accumulated balance and the original amount. Right? So you're essentially doing new minus old over old here. All right. Now your annual return is the average annual rate at which your money grows over a certain time period. Right? So when you consider the changing interest rate over a certain time period, the amount is the constant APY that would have produced the same result as the varying interest rate. So you're essentially finding the average interest rate, or the APY, that would have worked just the same, right? So of course, A is the accumulated amount, P is the principal amount, and T is the number of years. Okay. So we invest $3,000 in the Clearwater Mutual Fund, and over 4 years, your investment grows in value to $8,400. We want to know what are the total and the annual returns for the 4-year period. Well, we know that the total return is given by A minus P over P times 100. So in this case, it's 8,400 minus 3,000 over 3,000 times 100. So if we calculate this, we're going to essentially be taking a 5,400 by 3,000. And then if we multiply that by 100, we're going to get that this is 180%. So your total return was 180%. Okay. Now, and of course, this is a percentage increase. So you're increasing by almost 200%. Now, the annual return is our average interest rate that would have also worked. And that's where we have A over P to the 1 over T minus 1, right? So that's this formula here. So now to plug in this information, our A was 8,400 and our P was 3,000. I'm raising that to the 1 over 4 because it was for 4 years and then subtracting 1. So I want to do 8,400 divided by 3,000, raise that to the 1 over 4 and subtract 1. And that gives us that our annual return is a 0.29356. And of course, if you want this as a percentage, this would be 29.36%. We'll just round there. All right, so those are our total and annual returns there. Okay, so we'll do one more calculation involving this. So here we have that we purchased shares in newweb.com for $2,000, and 3 years later, we sold them for $1,100. So it looks like here it went down. So now the total return, our A minus P over P times 100, will in this case be 1,100 minus 2,000 over 2,000 times 100. And if we do that, again in the calculator, we got negative 900 that will end up being divided by 2,000. And then if we multiply that by 100, we're going to get a minus 45%. All right, so you lost 45% of your initial investment here. Right, and of course the annual return so this would again be A over P to the 1 over T minus 1. So in this case, we have 1,100 over 2,000 to the 1 over 3, because we're over 3 years, minus 1. So now if we do this calculation, we have 1,100 divided by 2,000 to the 1 over 3, and then subtract 1 from that. And we get this is a negative 0.1807, which means that we're losing 18.07% per year for each of those 3 years. All right, so those are your total and annual returns there. All right, now some final comments about some different types of investments. 3 things that we have are, well, the first one being stock. Right, so stock is sometimes called equity, and this gives you share of an ownership in a company. Right, so you invest by purchasing shares of the stock, and the only way to get your money out is to sell the stock. Right, and because stock prices change with time, the sale may give you either a gain or a loss on your original investment, depending on at which time you sold your shares. Okay, of course, the next thing is a bond, which is sometimes called a debt, and it represents a promise of future cash. So you usually buy bonds issued by either a government or corporation. The issuer of the bond pays you simple interest and promises to pay back your initial investment plus interest at some later date. Right? And of course, the last one is cash, and cash investments include money you deposit in bank accounts, certificates of deposit, and U.S. Treasury bills. And cash investments, of course, generally earn interest. Right. Now, as far as investments go, there are two basic ways to invest in any of the categories that we just talked about. You can either invest directly, which means buying individual investments yourself, or you can do this through a broker. And you can also invest indirectly by purchasing shares in a mutual fund through which a professional fund manager invests your money along with the money of others participating in the fund. Right, so you can almost think of it as you're either doing individual investing or group investing. Right. Now, some things to consider with investments. The first one is liquidity. Right. So how difficult is it to take out your money? Investment from which you can withdraw money easily, such as an ordinary bank account, is said to be liquid. The liquidity of an investment like real estate is much lower because real estate can be difficult to sell. Right. So the idea behind liquidity is how quick can you get your money if you wanted it. Now, another thing is risk. Is your investment principal at risk? Right. So are you at risking losing the money? So safest investments are federally insured bank accounts and U.S. Treasury bills because there's virtually no risk of losing the money that you invested. Now, stocks and bonds are much riskier because they can drop in value, in which case you could lose partially or all of your principal amount, right? So that's, of course, more risky. And the last investment that we need to, investment considerations that we'll discuss here is the idea of return. How much return can you expect on your investment? Which means how much money are you getting out of that investment? So a higher return means you earn more money. Now, in general, low-risk investments offer relatively low returns, while high-risk investments can give you the prospect of a higher return, but you can also lose what you started with as well. So, of course, then the question becomes, how do we balance risk and return? So what happens is that financial analysts will look at an index that describes overall performance of some category of investment. And of course, the best known index is the Dow Jones. Right. So this reflects the average prices of the stocks of 30 large companies, and it's used by financial analysts to look at the overall performance of investments in these 30 large companies. All right. So that concludes this section on savings plans and investments. I hope you enjoyed, and I will see you next time.